Hello there. I'm going to be talking about my final project, designing 3D topography. So I'm pretty sure everyone knows what this is, but I'm going to go more into detail about it since some people might not have seen it before. This is a height map or a topographical map. Basically, it shows the different elevations of varying points on any given setting. So for this map, I just chose Earth. You can see the hills, you can see the Himalayas there, various mountains across the world. Here's the Andes. Basically, it's just showing elevation. That's pretty much it. This map is kind of going more into detail because it shows the underwater elevations, so we can see like the ridges in the oceans, you can see the plates underwater and whatnot, but that's not that important. This map is very useful. It's used a lot. It's been used by governments, by scientists, by explorers, etc., etc., etc. Very common map, which you might see just in your everyday setting. Now, this kind of map can be shown in a lot of different ways, and one of the ways is through relief maps. Now, these are highly exaggerated height maps. Basically, what you've got here is that you've got a standard, topographical map, but you exaggerate the features to make it a lot more palatable to the eye in some way. I mean, you're just kind of making it easier to register because it doesn't, I mean, they don't look like this from space. Like these mountains aren't that high. These are usually exaggerated by like a factor of 10 or 100 or something, or I think a lot more than that actually, but you get the idea. They don't look like this from space. It's a lot larger of a landmass, so it looks a lot more flat from orbit. But the basic idea is they look a lot more normal to how you'd expect something like the mountains to look. And you can kind of sometimes see this thing on globes where they make like the mountains a little bit more bumpy. Like you can run your hand over it, and the Himalayas might be a little bit more shaky. So what my main idea was is I really like the graphical design of these maps. They look very interesting. They're unique, and they get a lot of attention online usually. Like I found these on Reddit. They got a bunch of popularity, very, very viral. So people have made a lot of things like this. But I wondered, I mean, they look physical enough. Like I feel like I could touch these mountains very easily, which I guess is the point. But furthermore, they look like actual 3D files. So what I figured is that I could maybe turn these into a actual 3D object using our lab's 3D printers, which seemed pretty doable because I knew a few techniques which I could use, which could bring the idea to fruition a lot quicker. So this is a STL image making. An STL is basically just a 3D file. But what's unique about them is that you can turn any regular image into a 3D file. This image right here is not, it's not actually, I'm not actually turning this image of a pug into a fully modeled 3D animal, but this is the general idea. This basically could be a height map, a gray, black to white image, um, and then that could go and become a 3D visualization, basically. It's it's not too complicated to explain, but when you like word it out, it comes a little weird. But the point is that you're basically taking the lightness on an image and attaching that to a value of a height. So let's say I make black super low and high, and white super high. That'll make it so the image registers white is like a mountain and black is like a valley. And so using those images, you can make a physical, touchable 3D height map. And I thought this could be really interesting if you use concepts like what if you made the largest mountain in the solar system, Olympus Mons, on one of these 3D relief maps. And so that's why I decided I would go with a project, but I would also add a unique flavor to it by perhaps 3D printing the entire surface of Mars, or I don't know, Venus or the moon or whatever. Because I think I mean, we've all seen Earth, we've seen the Himalayas, we've dealt with that, but we have not seen the solar system. So that is where we went with it. I'll show you just the actual process, and then we'll also show you the results. Right, so here we are on the nasa.gov official website, or I think it's the official website, but this is where you can usually find any kind of height map. You want to look for something that's kind of like this, where you can see it's got, very clear elevation mapping. So you can see here the Alps, you can see the trenches and rivers are very dark, and the peaks are all white and high. And then that'll give us some good visuals when we turn it into a 3D model. So you're going to want to take this image and bring that to another website. And also with the kind of image you're choosing, you probably want to go for something that's not too big. This image is huge, it's massive, and this one's kind of small. So keep an eye out for that, because if you get something that's too big or too small, it's going to cause issues later in the line. So get something in like the middle ground here. But anyways, we're going to take it to this website called Image2STL. There's a lot of different websites that do this. This is just one of the most useful, simple ones that I could find. All you have to do, you upload the file onto it. We'll edit these later. Convert to STL, and voila. Now it looks pretty crazy right now because we have to turn down the exaggeration. Currently, it's a bit too sharp and too high because it's kind of hard to even recognize it as Earth. So what we're going to do is going to go to Edit, and we're going to turn the height up. Let's put it up to let's see. Let's try 5. And then also we're going to want to go to Options and enable smoothing. And let's see how that looks. So I find it's better to just kind of experiment with the kind of height you want. This one I've got at a 15. Let's see, let's try just 20 to see how it looks. It's going to make it kind of flat. Let's see. Yeah, so it's barely even noticeable at this point. It depends on how exaggerated you want your height map to be. So for this example, this might look nice if you put like a texture over it, which showed where the mountains were, and it's more of like a subtle little bump, like on a globe. But if you want it to be super high, you might just put it on like 2. And then that's going to be, very exaggerated. So let's go for like a middle ground. Let's do like a 6. Let's see how that looks. It's pretty nice. I think this is generally what I went for. I don't remember the exact number, but something like this looks pretty good. Usually when you print it out, it's noticeable, but it's not too crazy. Let's see how 5 looks. And there. Yeah, so this looks good. So you've got your STL. What you want to do now is just download it. And then once that's downloaded, all right, now we're in Prusa Slicer. Here's my current setup. I don't know what kind of printer you're using, but this is the one that we have in the lab. So what you're going to want to do is go to import STL. It doesn't matter very much what kind of STL you're importing because they're usually the same. And then go to your file. And that'll bring it in. Do a little bit of loading. This one's pretty big. There's a lot of different things you can do here. For one, you can just scale it. You can make it really small, like that. This will print something pretty quickly. Pretty small. It's pretty manageable for the printer. But what you could do, and what I did, is that you can split your STL and then do 2 separate prints. So let's go here. Or I think it's like this. You're going to move the slice, basically, is what's happening. So find the axis. That's not right. Oh, like this one, I think. You're going to want to rotate that. Try and get that accurate. Like 90. Oh, there we go. And good enough. There we go. So now we've got it split right on the meridian. So with that done, you can perform cut. and you've got 2 slices of your print. So let's say we just want to print the Americas for now. We're going to remove, by deselecting, I'm going to remove the other side of the world, and we're just going to bring this one piece way up, like so. So with this piece, now you can just print this. Let's see, you can go to slicing, wait for that to do the infill. Let's see how that looks. All right, here it is. This looks pretty good. You maybe want to reduce the infill because this will take a minute. It says it'll take about 2 hours. Looks pretty solid. Yeah, the mountains might look a little weird. I know there's a way to get higher detail if you want like your mountains to look less kind of ribbony. But I don't remember exactly how to turn that on, but you can, that's definitely an option if you really don't like how it looks. But I think this is good enough. The mountains look pretty realistic, and you're getting the general idea since you're probably not going to be looking that close. So then you got your height map. To bring back the other one, you just press Control-Z, you go back, and then you just do the other thing, except this time with this one. You flip it onto its face, like so, and then it's pretty much just the same thing. You scale it, bring it up, and you slice. And so once that slices, let's say you presumably have your other slice or other model printed out, you can just do that. Sliced up, take about 2 hours and 30 minutes, and this looks pretty good. With that complete, you can export the G code and then feed that into your printer, and you've got a wonderful little 3D height map made of polymer.